Let's get practical. You have a 3D idea, maybe a bracket, a part, or a new invention. But you can't just hand someone your thoughts. You need a universal language orthographic projection. These drawings are the contract between designer and builder, packed with every detail needed for precision. A machinist anywhere should be able to build your part from your drawing. No words needed. Orthographic views eliminate ambiguity, critical when tolerances are tight. Think of them as recipes, not just bake a cake, but every ingredient and step. They flatten 3D objects into clear 2D views, showing every feature with clarity. This is the foundation of modern manufacturing. Mastering this skill lets you read blueprints, design confidently, and communicate like a pro. It's the difference between tinkering and true engineering. With a few key concepts and some practice, you'll be blueprint ready. Let's dive in and build your foundation. Time to become a blueprint reading, part designing machine. Here's the glass box method, my favorite way to visualize orthographic projection. Imagine your part inside a clear, six-sided glass box. Stand in front and trace what you see onto the front panel. That's your front view. Move above, trace the top. That's your top view. Stand at the right, trace again. That's your right side view. Now, unfold the box. Lay the panels flat. You have three perfectly aligned 2D views. Top above front, right side to the right. This arrangement is the core of orthographic drawing. Each view shows the object from a single, perpendicular angle. The glass box trick makes it easy to mentally flatten any 3D object. It's a simple, powerful tool for clear communication. Practice this method and you'll never get lost in 2D again. That's the secret to seeing like a drafter. Ready to try it? Not all views are equal. The front view is your anchor. Pick the side that shows the most detail and the fewest hidden features. The top view sits directly above the front, sharing the same width. The right side view goes to the right, sharing the same height. This strict alignment lets anyone connect features between views instantly. Together, these three views describe height, width, and depth. But you don't always need all three. Use only as many as needed for clarity. For simple parts, one or two views may be enough. For complex shapes, use more. The goal: clear, unambiguous communication. Always start with the best front view. Build the rest around it. That's how you tell your part's story efficiently. Lines are the alphabet of your drawing. Visible lines, thick and solid, show what you can see. Hidden lines, medium, dashed, reveal edges you can't see directly. Center lines, thin, alternating dashes, mark centers of holes and axes of symmetry. Dimension lines, thin, with arrows, show measurements. Extension lines connect dimensions to features. Cutting plane lines, very thick, with arrows, indicate where a section is taken. Each line type has a job. Using them correctly makes your drawing readable. Hidden lines let you show internal features without extra views. Center lines clarify symmetry and hole locations. Mastering these lines is essential for clear, professional drawings. Think of them as your drawing's grammar. Use them right, and your message is crystal clear. That's the key to communication in engineering. Here's a common pitfall: projection standards. The US uses third-angle projection, the glass box method, where top is above, right is right. Europe and much of Asia use first-angle projection, which flips the views top below, right to the left. Mixing them up means disaster, parts built backward. Every drawing should show a symbol, a truncated cone, with its side and circular views. Third-angle circle to the right, first-angle circle to the left. Always use your region's standard and include the correct symbol. That's how you avoid costly mistakes. Know your projection and label it clearly. Let's draw an L bracket. Vertical leg, horizontal base, hole in the leg, slot in the base. Start with the front view. Show the L profile and the hole as a circle. project the top view above, a rectangle for the base, with hidden lines for the hole and visible lines for the slot. Right side view rectangle for the side, hidden lines for the hole and slot. Align all views perfectly. Add center lines through the hole and slot. Dimension overall height, width, depth, material thickness, hole diameter, slot size, and feature locations. Check, is every feature's size and location defined? No ambiguity. You've made a manufacturable drawing. This is the process for any part. Choose views, align, add features, dimension, and check. Practice this, and you'll design like a pro. The L bracket is just the start. Every part follows these steps. Ready to try your own? Sometimes hidden lines aren't enough. Complex interiors need clarity. Enter the section view, slice the part open, show the inside with clear, visible lines and hatching. Use a cutting plane line to mark where you cut. Section views replace confusion with instant understanding. For angled features, use an auxiliary view. Project perpendicular to the slanted surface. This shows true shapes and sizes, perfect for dimensioning. Section and auxiliary views keep your main drawing clean and readable. Use them only when needed for clarity. They're your tools for solving tricky geometry. Clarity is always the goal. A drawing is more than views. It's a complete document. The title block, usually bottom right, holds the part name, number, drafter, date, scale, material, tolerances, and projection symbol. The scale tells how drawing size relates to real size, full, reduced, or enlarged. General notes cover details like units, edge breaks, or assembly instructions. Good notes answer questions before they're asked. A complete drawing is a self-contained package. Don't skip the title block or notes. They're as vital as the views. Professionalism is in the details. That's how you get your part made right. Mistakes happen. Learn from them. Top goof misaligned views. Always align top above front, right to the right. Use construction lines or KD tools to keep everything in place. Next, wrong line types. Visible lines bold, hidden, and center lines thinner. Don't over or under dimension. Every feature needs size and location, but only once. Double dimensioning causes confusion. Missing dimensions waste time. Pro tips: pick the best front view, most detail, fewest hidden lines. Keep dimensions grouped and tidy. Avoid crossing lines. Think like a machinist. Would you have all the info you need? Review your drawing before calling it done. Clarity and completeness make you a pro. Practice, and these habits become second nature. That's how you level up your drawings. Time for a quick quiz. Grab paper and answer these. What's the main purpose of the front view? Show the most characteristic shape, fewest hidden lines. In third angle projection, where's the top view? Directly above. What line shows a hidden edge? Dashed line. How do you show the true shape of a slanted hole? Auxiliary view. What's the box with part name, scale, and material? Title block. Check your answers, review if needed, and keep practicing. You've learned the essentials of orthographic projection. It's a logical system for turning ideas into precise instructions. The glass box method, principal views, and line types are your new tools. You know the difference between first and third angle projection. You've practiced with an L bracket and learned to add section and auxiliary views for clarity. Title blocks and notes complete your drawings. Avoid common mistakes, use pro tips, and always think about the builder. This skill bridges imagination and reality. Start sketching, designing, and making. Your ideas are blueprint ready. Go create something great.